Okay, what I'm going to try to do is go back. I missed a couple of lessons and I forgot to hit the record button while we were doing class. And so I thought maybe what I should do is go back and just do a recap of the class. Now you won't get all that interaction like we normally do where I ask questions and stuff like that. I will try to ask a few questions as we go, but I thought instead if you just knew what we talked about, then you can go back and watch the whole series and pick up everything. Most of the things I'm going to talk about in today's lesson, this is actually lesson number 2. We did, our first one was kind of an introductory class, and then we did that first lesson. I did record that one and I put it up. And then the second one, I got so excited, and it talked about a lot of botany, and I talked a lot about a bunch of math, and then at the last minute I squeezed in some last minute quantum mechanics on elements. And so I thought maybe I should go back and just do that slowly so you can see what we talked about, and so you don't have to listen to like an hour and 15 minutes. Maybe I can boil it down and it won't take us quite so long. I am going to be experimenting with a couple of things in this lecture, so be patient with me as I look at the screen and try to figure out how to do a white screen and how to draw some things for you. That's what I'm going to try to do. If the other students happen to watch it and I missed something that I actually did cover in that class, but I forgot to mention it, hopefully in the next lecture, in the lesson 3 lecture, I go back and I recap this lesson as well. So you may get part of it here, part of it there. All right. So let's talk about botany. We're going to start there because that's how I kind of got out of hand with our other one. Let me try to get my screen up here. I'm going to get a whiteboard. Okay. Can I pause? I don't know if I can pause record. Okay, here I am. I have a whiteboard now in front of me. Hopefully you can see that as well. And I am going to draw. Let's do a basic leaf, okay? And I'm sure we've already talked about this before. How did I get out of control lesson? Okay, so here is our basic leaf. Okay. All right, there's our basic leaf. And I want you to, we're going to name parts. So let me just draw in this. Okay, that's a vein. Wow, this is like really difficult to do. I don't know if you guys have ever tried doing this, but it's not as easy as they make it appear when you watch YouTube videos. But see, again, I think we've covered all of this now in the most recent lectures, so you're going to feel like you already know this, what you do. Okay, let's try to take that all the way down. Okay, here's a basic leaf. This part right here is called a petiole. Oh wow, this is going to be like really, really big. Let's see. Let's move that over like that. That area right there where it is attached to, this is where it attaches to the stem. That is called the petiole. The main part of, I'm trying to find out how to get, okay, the main part of the leaf like this is called the blade. Okay, the end right here is called the apex. And one more thing, these things in the middle, okay, are called the veins. See, I believe that we already talked about that. What we added this last week, okay, so most of you, again, you already know this, the edge of the leaf is called the margin, okay? Let me select that a little bit closer. Okay, so those are the basic parts of the leaf. And we took time in class and we wrote all of that out. Now we've already talked about some other vein formations or vein arrangements, okay? This particular arrangement where you have one main, let's see, come on. Where you have one main vein going up to the end, and then these coming opposite each other, okay? This is called pinnate. Maybe I should write that. Wow, this takes a while. Sorry. Why is it not letting me drag it? There we go. That's pinnate. Okay. Then the other thing that we covered in class at time was the difference in a simple leaf and a compound leaf. This is an example of a simple leaf. If it attached to the stem right here at the petiole, it's just a single blade straight onto the stem, then that's a simple arrangement. A compound arrangement is if you have, let's see, let me draw a straight line first, okay? Because this is going to be my stem, all right? That's my stem. And then coming off of the stem, let's say we have a series of leaves that look like this. Oh wow, this is like not going so well, is it? Well, you understand the basic idea here, I think. You know, all I'm trying to do is get you to picture it, okay? So that's all I'm trying to do here. I'm not trying to draw you a perfect picture. Well, thank goodness for that. And all right, must I go all the way to the end? I guess I must. And then let's just do like one out this side. Because that's usually what they look like on the end. Okay. And let's just pretend like somebody picked off two. Right? Because there's two missing right there. All right, so this whole thing, if our branch, the branch of the bush is coming by here like this, okay? Hey, this is about as good as my drawing on the board, isn't it? Okay, so there's our branch going by, and that's how the stem attaches to the branch, okay? This whole thing. Let's see if I can change colors. Okay, this whole thing is considered to be the leaf. Okay. Okay, so that is called a compound leaf. And you can see why it's called that, because you have each of these little or smaller leaves attached to one stem that attaches to the branch. And so that's a compound leaf. This one is simple on this side. This one is compound. Maybe I should put that over here. This is a simple leaf, right? Because what we have is it's attached to our branch like this. Come on, Mrs. White, draw a straight line. See if you can draw a straight line. I can't. Okay, that right there is our branch. A single leaf attached to a branch is simple. One larger group. Okay, so that's compound, simple compound. Now there's one other way that leaves, there are also ways that leaves can be attached to the branch. Okay, so we went into that too. This is why I took way too long this class and covered way too much botany, but at least we got it. And the next week we didn't talk about botany at all. We skipped it. So this is to catch you up with what all we know. Simple, compound, the parts of the leaf. Now there were three ways that leaves could be attached to the branch. If you look at this one right here, our compound leaf, do you see how each leaf is exactly opposite of the one over against it? So this is actually called an opposite arrangement. Okay, the leaf is exactly opposite another leaf. Again, I'm making it look very flat, but keep in mind that they can be, like one of those leaves could be towards us and then the other leaf would be behind the branch, but it still would be connecting at the same point. So this is called opposite. Okay, another way, let's draw. Let's see, I am drawing, aren't I? Okay, so let's draw this stem. Here we go, here's our stem. Don't know why it gets so hard for me to do this, but that's our stem. Okay, that's our stem. Sometimes a leaf might be attached here. Okay, and then a little farther up, there's another one. And a little farther up, there's another one, like this. If this is making sense to you. Okay, and then maybe here, there's another one. Do you see how they're not lined up? They're not lined up opposite, like one straight across. This is called alternate. Okay, alternate arrangement. Maybe I should type that in. Okay, right here. Let me change my writing to orange. Okay, this is opposite arrangement. This is alternate arrangement. Okay, and now let's go back to our, actually the red worked pretty well, I thought. Okay, for the last one, wait, this didn't work, draw. Here we are. For the last one, there are some leaves that all attached together. Let me think for a second, because there's two different ways I can do this. There's sessile and there's whorled. I think I'm going to do the sessile next. I'll show you an example of this. Okay, here's my stem. Okay, and in this case, the leaf itself just comes right out. Okay, imagine this. Okay, you can see there where the leaf itself wraps around the stem here at the bottom. That's kind of tricky. It's kind of hard to tell that that stem is coming up through that leaf. But here, let me show you one. I've got an example right here. Let me break it off, and then I'll show it to you. See if I can find a good example of it, like right there. Okay, so now here we have our stem. You can see the stem. And if you see this waxy part right there that is going up, this leaf is actually growing where the stem comes right out of the center. So can you see that? You can see there how the leaf itself is wrapped around the stem. It doesn't just come out of the stem like the petiole. The leaf itself is wrapped around the stem. So trying to get a better view of, okay, I guess that's probably the best view I'm going to get of it. Okay, there you have that. Maybe look at it from underneath, all around. Okay, that's called sessile. This particular type is called sessile. That's how it's attached to the stem. Okay, so I think that's all we talked about in the botany part. We talked about parts of the leaf, simple, compound, sessile. We did alternate and opposite, and the last thing we did was called whorled. But I won't make you worry too much about whorled, because we don't see that very often around here. Mostly in the tropical plants, you'll get whorled, where they just all come out of the bottom. Okay, all the leaves come straight out of the bottom instead of being attached. So that was the botany part. And then I did this very long math thing where I had them draw a point and draw lines through the point. And then I had them draw 2 points and draw a line connecting the points. I was doing all of this. We were going to work towards doing circumference, perimeter, and area, but I've kind of got that on hold for right now. So even though they did a whole bunch of math, I'm going to let you skip it right now. We won't work on that. We will go right over to our next part, which I thought was very important. I talked about John Dalton. You'll hear, you've got the handout probably. If you read that handout, you'll see that he was a very meticulous scientist. He paid attention to things, took very good notes and wrote them down. And so, okay, give me a minute. I want to make sure that I'm still videoing. I think I am. I can't quite tell. But anyways, so John Dalton, I need to make sure I'm videoing because recording. Let's see. I assume I'm still video recording here. It's not letting me see my control panel. But we will just assume that I am, because I've got a green button right there. I believe that means yes. So we talked about John Dalton, and he paid attention to details and made recordings. And because of those details, he was able to say that he believed everything was made up of particles called atoms. This theory didn't start with him. He was the first one that was able to prove it and to do some experiments that made it even more plausible than before. But actually, there was a man named Anaxagoras back 800 years before Christ, who also said the same thing, that everything in the world was made up of particles, but he couldn't prove it. And then in 400 AD, after Christ, I mean, the year 400, Democritus also made the same observation. So this theory is, been going on, but Dalton helped to prove it. That's more what he did. And he came up with, I think, the four main things I wanted you to remember of Dalton that he said is that all matter is made up of atoms, which are indivisible. Okay, you can't split them apart, according to him. That elements are atoms that are the same. Okay, elemental atoms are the same. And that all things are combinations of these atoms put together in other ways. Kind of like, we know today, that's molecules. You take the elements from our periodic table and you put them together in various ways and you construct different things, just as a different combination. So that was true. And that he said chemical reactions are recombinations of these atoms, which ends up being true. The one thing that he said that is not true is that he said atoms were not divisible. And we then learned that atoms are divisible. They're made up of parts. They're made up of pieces. But you have to give him credit, because once you take an atom apart, it doesn't act like an atom anymore. So you can't build something from these subatomic particles. So he's right in the sense that an atom is the smallest element that can be put together to create other things. Once you divide this atom, then you can't use those individual pieces to build something else, if that makes sense. So I still kind of give him credit for that, even though we do know that there are subatomic particles, which leads us to quantum mechanics, how the atom's actually made up. So let me erase this board, clear all my drawings, and it's just gone. Isn't that amazing? Let's see, clear. All right, so there you have it. Now I've got a clear board. I'll keep with red, I think. So we then talked about the atom itself. Atoms are made, most everyone knows, okay? Atoms are made up of protons, neutrons, and electrons. Okay, those are the three bigger pieces inside of the atom. Okay, the atom is the smallest particle that can then be put together to build other things. But it is made up of, these are the three that most everyone just kind of knows. But what I wanted to take you into is the makeup of protons and neutrons, okay? Because they are actually made up of smaller particles, even things smaller than the protons, neutrons, and electrons, which is amazing. And these pieces are called quarks. Okay, quarks. What a strange name, I know. But, once you get into this kind of subatomic particles, then you get really strange names, fermions and leptons and antimatter, antineutrons, things like that. But let me just try to take you through this pretty quickly, okay? Don't know why my line is going up there. Let's erase that line. Let's just kind of, oh my goodness, I erased the wrong thing. wonder if I can do a Control Z. Nope. Okay, let me type that back. Okay, we have protons, neutrons, and electrons. All right, and I wanted to draw a line. Neutrons and protons are made up of quarks. Very good. There we go. So let's talk about how this goes together. Okay. Each one of these has three quarks each. Okay. There are 6 different varieties of quarks. You're just going to learn 2 of them. You only have to learn 2. Okay. We have what we're going to call an up quark. And we're just going to draw it like that. Okay, that's an up quark. And then we have a down quark. Think of it like that. Okay, think of them as like earthworms or something that are, okay, and he's not just an up quark turned upside down, okay, this is a down quark. So let me try to move that. Sorry, not very good at this. That's an up quark. This is a down quark. Each one of these carries a charge, just like in electricity. If I have one thing that is a positive 1 charge and one thing that's a negative 1 charge, and I put them together, they neutralize each other. So there's a charge of 0. Okay? If I have a positive 2 and a negative 1, then this one cancels out this one, and you've got an overall positive charge. Okay? So the up quark has a charge of, let's see, how can I write this? Let's see, up quarks have a 2/3 positive 2/3 charge. Let's put a positive in front of it. I'm going to choose this and I want to move it down. Okay. A down quark has a negative 1/3 charge. Negative 1/3 charge. So we went through all of this in class, okay? If a proton, okay, our proton here, he has a charge of +1. And he's made up of 3 of these. I can have 2 of one and 1 of the other, okay? So I said, can you think of a way to mix these together so that you end up with a +1? And I believe Austin was able to tell us that if you have 2 up quarks, okay, 2 up quarks, then that's 2/3 plus 2/3 gives you 4/3, right? It gives you a positive 4/3, okay? And then if you have 1 down quark, then you have a negative 1/3. So you can see how 4/3 minus 1/3 would give you a positive 3/3. And there is our, that's the same as 1, isn't it? So you see how 2 up quarks and 1 down quark will make a proton. Now if I reverse it and make 2 down quarks, that's -1/3 plus a -1/3 is a -2/3. And you mix it with a +2/3, they cancel each other out. And you end up with a neutral, okay, or a no charge, and that's our neutron. That's a lot, okay. I could have just said, remember that a proton is made up of 2 up quarks and a down, and a neutron is 2 downs and an up. But I wanted you to see how the charges work out and how that fits together. So then I had them look at the periodic table, okay? So I can tell you a little bit about the periodic table. Here's our periodic table. And I'm just going to show you a couple of them, okay? Because it's 2 pages, you have that, I'm pretty sure, okay? In the periodic table, you have these boxes. That's rubidium. Okay, let's find something. Let's start with something simple like hydrogen. There's your hydrogen, okay? And the number that's in the top left corner right here, that little number 1 tells you how many protons are in that atom. So hydrogens have 1 proton, okay? You could also say, oh, it has 1 proton, so therefore it has 2 up quarks and 1 down quark. But I mean, you don't need to go into quarks because all we're trying to do is learn the ratio of protons to electrons. For every proton, there is 1 electron. So in the hydrogen, obviously, he's got 1 proton, so he's got 1 electron cycling him. And then if I moved to, let's look a little further, there's lithium, okay, lithium. He has 3 protons and therefore 3 electrons. They balance each other. Now in the next lecture, I go more into what happens and how those electrons that are in the outer shell are going to leap and jump and all that kind of thing. But for this lesson, that's pretty much all I wanted to cover. Like I said, the next lecture, lesson 3, it covers more of what I want you to know and how an element or an atom creates light. I hope this helps. Let me know if this was helpful. Okay, so I'm going to close that and go back to here. All right, I think that's it for lesson 2. So I'll try to get them in order on my channel. This was lesson 2. Lesson 3, I cover some of this again. So I hope it helps. Thanks. Bye. Let's see.